Hey everyone, how's it going? This is Ali from the AI Enthusiast, and today we'll be covering lecture 5B. So, in the last lecture, we talked about computer vision and natural language processing. In this lecture, we'll be talking about radio frequency machine learning. We'll also be talking about audio machine learning, applying ML AI to audio, and then we'll be talking about tabular data. So, let's jump right into it. So yeah, I think everybody knows what audio data is. What is radio frequency data or RF data? So basically, this is data that's going to be captured off of an antenna of some sort. So you're going to have, you could have radar data, you could have data off of Wi-Fi, you could have data off of your cellular device, and there's a lot of other things that you could get data off of. But at a high level, definition wise, we're talking about teaching computers to make sense of audio data and then radio technologies. And so the data here, we have RF data, radio frequency data. This is going to be a stream of complex numbers. So a complex number has a real and imaginary component to it. In short, to simplify it more, it's just basically a list of numbers. And there are different data formats and standards. I just listed some common ones there. You've got SIGAMF, you've got VIDA49, which is a standard. SIGAMF is going to be like a file format for training up ML models. Then you have audio data. So this is going to be this is going to be an image. It can be a stream of numbers, just like RF data. And there are many different types of file formats, as you are familiar. You might be familiar. So you have the WAV, WAV, MP3, etc. And let's take a look at the bottom right hand side here. You can see how time so when we capture this data, whether it's RF or audio, it's going to look like what you see on the red here. So you're going to have basically a bunch of samples that came in, and it's varying with respect to time. And what you can do is you can take something called the discrete time Fourier transform, and you can convert that into the frequency domain. So now you can look at it from a frequency perspective. And furthermore, if you want to do both a time and a frequency view, you can look at what's called a spectrogram. So there's many different ways to look at this data and transform it. So you can look at it from like a just a stream of numbers, or you can convert it to an image. And with this, you can do many different types of common tasks. So you can do sound classification, you can do speech to text. Then once you have it in text, you can also do text back to speech, so audio generation. And furthermore, you can also do like sound generation. And then, with radar, you can classify different objects. You can also do some sort of filtering of false detections, so speed detectors on the road, all sorts of things really. And this is just a very short list. Now moving on to regular data. So what I mean by that is it's going to be collected in the form of like JSON or text or CSV. Again, these are just different data formats, and you can take a look online what they look like. But these are usually going to be related to some sort of business event or some sort of business like entity. So before we go into the text, let's go to the bottom of the screen. So in this example, we have movie recommendations. And so what I mean by business events, each row is basically a user watching a particular movie. So we have this historical data, and this probably arrived in JSON format. And then we made this big table out of it. And as you can see here, user 3 has watched Adventure Movie 1 and Action Movie 2. And furthermore, user 1 has watched those same movies. So now we can say, okay, well, user 1 also watched Action Movie 1. So we know first off, user 3 likes action and adventure types of movies. And then secondly, user 3 is very similar to user 1. And so because of that, we can infer that user 3 might like Action Movie 1 that user 1 watched. And that in that manner, we can recommend to user 3 things that user 1 has watched. And so this is a good example of looking at tabular data. And this is what I meant, is that essentially we take these events, we put them in a table format, and we can do all sorts of machine learning on them. And so here, let's go up to the examples then, going through the text. So in the advertising domain, an example is looking at similar customer behavior. So we already talked about movie recommendations, but you can also look at purchasing products. So in that case, each row in this table would be a user and then the product that they bought. Also, then you have product similarity. So in this scenario, you're just looking at products and their attributes. So you have size, weight, color, category, subcategory. For each product, have like a substitute. So then if we do run out of a product, then you can recommend the substitute product to the customer. And then supply chain is looking at like prior performance of vendors. So whenever we have a purchase order with a vendor, you can look at when the arrival time was promised and then when they actually delivered the product. And then based off of that, you have data to then analyze and use possible machine learning algorithms to predict their performance during holiday season when it's very critical that you get the product in. Another example is cybersecurity. So this is you're looking at your network data. So you have the OSI model, and you have basically security information and event management. So that's the type of database we're looking at, and from there you can come up with patterns to maybe detect some sort of intrusion. And I actually might make another video. So lecture 5, part 3, basically talking about cybersecurity in more detail because it does have its own like type of data. So, but yeah, that's pretty much it for regular or tabular data. Anyways, this was the lecture for today, where we covered audio and RF machine learning, and then we covered regular data, quote unquote, basically tabular data. Thanks so much, guys, and I'll see you in the next video. If you like this video, please like and subscribe. It really helps the channel. And if you have any other questions or comments regarding this video, please post them at the bottom. And take care. See you next time.